In order to increase the energy density of today's lithium-ion cells, there's a few different things you can do. One of the things is to increase the capacity of the active materials. This can be done, for example, using silicon in the anode, or moving to materials that have higher capacity on the cathode side. The other option is to use higher voltage materials on the cathode side. So things, for example, like high voltage lithium nickel manganese oxide. However, the challenges of using such high voltage materials is we also need to develop new electrolytes which can handle these high voltages. And so in general, in order to increase the capacity of the cells, research has to be done on all components, including the crosstalk between components, in order to have higher energy, higher capacity, but still a highly functional cell. Raw materials for lithium-ion batteries are certainly a topic that is of high importance, both worldwide and EU-wide. Lithium-ion batteries themselves use many materials that are considered critical. So lithium, nickel, cobalt, to name a few, those are the big ones. But if you go through the materials that's in a lithium-ion battery, you can somehow find a critical nature for all of them. Europe can certainly mitigate problems with the use of critical raw materials by looking for ways to keep materials in the value chain. So this is why recycling of lithium-ion batteries is going to be so important in the future, especially as the market continues to grow. The batteries that would come back after end of life is probably about a 10-year delay from when they go into service. So we also have to look at taking production waste from our gigafactories that are being built and recycling those as well. And these are two ways to help mitigate the issue of critical raw materials for batteries. The main objective is to recover the valuable metals, so things like nickel, cobalt, and copper. In the future, we need to work to recover more of the battery cells. So this implies things like the foils, the plastics, separators, possibly even electrolytes. On the EU level, the battery directive is going to set targets and also regulations of how much of the lithium-ion battery should be recovered. And to reach the targets that are given in this regulation, this is only going to be possible when recycling is extended beyond the valuable metals. So the current industrial standard for recycling of lithium-ion batteries is based on pyrometallurgical processes or hydrometallurgical processes. The new kid on the block is basically direct recycling. Direct recycling approaches the recovery of materials in a different way, in that you want to recover the materials at the material level, not at the element level. And so therefore you want to recover, for example, cathode materials and be able to, after a regeneration step, feed those directly back into the value chain, so directly back into battery production. This should reduce the ecological footprint of battery recycling and hopefully also in the future be more cost effective. Direct recycling, a real possibility is to integrate aspects for recycling. It's called a process design for recycling directly during LIB production. So this means basically trying to find ways that will not negatively impact the performance of a cell in its first life, but will make the recycling easier after. And so, for example, since most recycling or direct recycling processes are going to be based on aqueous processes, therefore, if you could possibly use aqueous processing or use binders during the production process that can be dissolved with water, this will make recycling easier.